Hello, my name is Thomas Röskin. I'm a professor in experimental fluid mechanics at ETH Zürich, and I'll try to describe a little bit the objectives of the SMARTAIR project that we recently started with SDSC. We are operating a wind tunnel to perform aerodynamic testing, and this sort of testing on our scale and especially in industrial scale is very expensive both in time and resources. And our aim is to develop a new strategy to optimize the data sampling that is performed in these facilities to get data with sufficient density and quality in a minimum amount of time. Now, what we normally do is we have a special aerodynamic probe that can measure the local flow velocity at one point at a time, and you have to slowly traverse that through the flow field to build up a complete map of the flow surrounding the test object, be that an aircraft or a bicycle or a car. And without guidance, you obviously have to do that in a deterministic and somewhat inefficient way. We hope that by having an algorithm, machine learning based, that can analyze the data that has been acquired already to predict where more sampling is necessary and thus guide the human operator with their probe to the points of interest. That in itself is a challenge, and we hope that if we can find a suitable algorithm, it can also be used to link this sort of guidance strategy to automatic sampling with a robot arm, which is obviously then even faster. That would be the first part of our project, to develop strategies to assess the data quality that we are acquiring and then to steer the probe, be that human-guided or machine-guided, to points of interest. The next aspect that is maybe a bit special at our application is that this all has to occur in real time. Time is at a premium in these facilities, and we want to have this guidance and data analysis happening while the measurement takes place so that we make optimum use of the time available.